Hello, Norbert here, energy engineer, and today talking in video number 25C how to calculate the energy capacity and the savings in our double thermal energy storage, which you saw in video 25A and B. And you remember that was about the double storage, warm and cold, with in between a heat pump. Yes, 25C comes with the C of calculation. And don't escape now, because you know as well as me that without calculations you can make no decisions. Calculations serve you to convince yourself about the technology that can bring you along the way to progress. Start to think for yourself and embrace the C of calculation. If you don't believe me and wonder,
Why can't I find this technology which he talks about in the do-it-yourself warehouses?
then please go through the calculations. If you find they are correct, then there's only one thing left to do.
Roll your sleeves up, put on your gloves, and open your instrument box.
This technology can be yours, even if you don't see it in the shops. You owe me no finder's or license fee, but I would appreciate that you hit the subscribe button and share this video with your friends. Let's now see how to calculate a few interesting parameters. For this situation, they are 1. The capacity of your thermal energy storage. 2. The velocity of charging your TES, your thermal energy storage. And 3. The price per kilowatt hour of your storage. Now I decided to make shorter videos on my channel in order to save your time. I see that this third or last item will take too much time, so I will postpone it to another video this week, and that will be 25C2. Okay, so let's start with the remaining two items for today. And you can look in the timeline, the red timeline, which is sectioned, and then you can navigate your way through this video. The capacity of your thermal energy storage, or TES, will be useful to decide on the size of your tanks. For example, if you have water at 7 degrees Celsius and it returns after doing its work at 17 degrees Celsius into the tank, then you have 1000 liter times 10 degrees times 1 kilocalorie, and that's 10,000 kilocalories, or 11.6 kilowatt hour of energy. That is only for a cold tank. You have the same amount in a warm tank if the working temperatures are, for example, 45 degrees to 35 degrees. Okay, it can be difficult to imagine that you can use both cold and warm water at the same time. That challenge is also present in the much applied concept of CHP, or combined heat and power. Maybe you know it. Therefore I will be very conservative and suppose you even don't use one of both. It's up to you to be smart and take 2 apples instead of 1. The reason that I work with such a high temperature is that I propose installation of fans on the radiators to get more cooling or heating. See video number 1, more energy from radiators. So at the price of €1,000 per kilowatt hour for a lithium battery, you would save nearly €12,000 on the investment and spend maybe €1,000 on the TES, even if you don't count the 12 kilowatt hour capacity of the other tank. But remember the 2 apples. Another parameter which we deal with today is the velocity of charging of the energy storage. That will be useful for knowing how much time it takes to charge, but also to discharge, and help you to choose the right size of the heat pump. For example, if you have a mobile airco of 7000 BTU per hour, that means it will give you 2 kilowatts of cold, and it will consume about 700 watts. That is a multiplication by nearly 3.
Unbelievable!
So you get 3 times as
Oh,
much
yeah.
for your paid or self-produced energy. This same airco will produce also 2.7 kilowatts at the hot side. Okay, on the cold side you can decrease the temperature of 1 cubic meter water with 2 times 2 kilowatt times 3.6 megajoule divided by 4.2 megajoule. So that means 1.7 degrees Celsius per hour. So that's the temperature decrease, the cooling effect on this cubic meter. And that's in theory without losses. Therefore it will charge the tank from the highest to the lowest working temperature. So from 17 degrees to 7 degrees. In 10 divided by 1.7, and that's nearly 6 hours. The warm tank will take 4.3 hours to charge from 35 degrees to 45 degrees, and this increase will be with a speed of 2.3 degrees Celsius per hour.
So what can I do after seeing this video?
Okay, like I said before, you can use the calculations which I showed in order to convince yourself about the feasibility of this technology. As it may seem like a challenge, that you are realizing your own thing, which you can't even find in the do-it-yourself warehouses, and which is a bit revolutionary because it completely abandons the paradigm that today everything is working on electricity. On a practical level, the calculations that I showed you will serve you to define the size of the system. And the second calculation will tell you how much time it takes to charge but also to discharge the system, so that you know how much autonomy you have. Later this week I will tell you about the cost of kilowatt hour of storage, calculated as euro or dollars per kilowatt hour. And yes, that's the same unit as you find on your bill and which you pay for each kilowatt hour. You should not miss that video. I hope this video is useful for you and that you don't scare away anymore from calculations. In that case, please like the video and share it with your friends and hit the subscribe button so that I can help you to become more independent and think for yourself and realize your own projects, which you cannot find on the market. Let's start the energy transition from the bottom, from us, normal people. I wish you a good energy.